Okay, YouTube, in this video we're going to introduce a couple of very commonly seen logarithms, and I am trying to look for a word other than common. A couple of logarithms that we use all the time in mathematics, and we're going to refer to these as the common log, but also the natural log. So with respect to the common logarithm, we say that a common logarithm, simply put, is just a logarithm with a base of 10. And so if we were to look at something that is, say, logarithmic here with a base of 10, like log base 10 of just, I suppose some number here. I suppose we could just say x equals what? Really what we're saying here then is if we write this exponentially, 10 to the power of something turned into something we would have known. Maybe this is 100, maybe this is 1,000. But we often, what I'm looking at here is that we often deal with powers of 10. So we'd say powers of 10 are common. Sorry, I just really wanted to emphasize this word common here. So since we often deal with powers of 10, like maybe like scientific notation, something like that, or astronomical measurements, astronomically large, or maybe like really small, we would look at something with powers of 10. And also, we look at, we would say the natural logarithm. And so we would say a natural log is a logarithm with a base of e. And so where this is our common log, a common log is really just a log with a base of 10. We would say that a natural log, and certainly we're going to look at this over here on the left, but a natural log has a base of e. So we say base of e. Here we have a base of 10. So the natural log, we would say that this is log base e to the, I suppose we would say some x turned into we don't know. But if we were to rewrite this exponentially, we could see that this is e to the power of something turns into x. And just to be honest with you, because we use so many exponential models that are of this form ae to the rt, and we have a base of e, then we often are going to be rewriting this with logarithms of base e. So we would say that log base e of x, one thing that we want to mention about this is that we can write log base e of x. This is totally accurate, but another way to write the same thing is just ln of x. And so these right here are the same expressions, and this ln, sorry to tell you, I mean, you would think natural log, they would call it nlx, but as far as I always think about it, it's the log natural, it's the natural log, okay, but the ln of x, and that really just means log base e of x, that's all that means. And when we talk about the common log, one other thing to say about this is that we often write the common log as just log x. These two statements also would be the same statements here. So just like when you write a square root, and we don't always write the square root part or the nth root on the outside, we just kind of write it this way. The default understanding is that if you do not write a base on your log, then you must be using the common log. You must be using a log base 10. So looking at these over here now, we'd say that the log base 10 of x is our common log, and we would just read this as log x. We would assume it is 10 if no base is listed. Okay. Now, when we look at the natural log, we say log base e of x. You certainly can always write it as log base e of x, but what I'm going to tell you is that everybody in mathematics is really going to be rewriting this as the ln of x, and that's how you would just read it, ln of x. And so we would say that that's the same as what we get as this expression over here. So what I want to tell you is that these are the most commonly used, I guess, log base values, and so they often earn their own buttons on your calculator. You can have a log base anything. You can have a log base 2, 3, 4, 5, 6, 7, 8, 9. As long as it's a positive base, it's not 0 or not 1. You can have any base you want, but because we always represent things with bases of 10 or base of e, you're going to see that you have your log button here on your calculator. It says log, so yeah, that shows up there, and we can see that if I clear that and I say my ln key, that would be this guy right here. And so with respect to a calculator, what I want to do is this. I want to evaluate log 8 and ln 0.3 using a calculator, rounding our answer to 3 decimal places. But I'm going to add in a little extra thing here. We're going to say check the result that we get. So in other words, check the exponent. And so what we end up with here is this. I suppose that we would say that this is log of 8, which is the same thing as log base 10 of 8. And so that being said, if we were to look at log base 10 of 8 equaling something, we'd say really what we're trying to answer is, hey, what could I take 10 to the power of to get 8? So now our calculator, the neat thing about this is because we often use log base 10, we could just type this in as log 8. And it says, well, log base 10 of 8 would be 0.903 if we're going out to 3 decimal places here. So 0.903-ish, we would say that this right here is approximately 0.903, but the value of our log right here is just 0.903. So with respect to what we have right here, when I say I want to go check this, what I really mean is I want to rewrite this exponentially and say that really what this means is 10 to the power of 0.903. So let me fix that there. 903 comes out to be 8 when we rewrite this exponentially. So I want to show you here, if we were to take on your calculator 10 to the power of 0.903, what you're going to notice is that we get really, really close to 8. And why don't we get exactly 8? Well, we don't get exactly 8 because we rounded off our exponent. If we had taken the entire exponent, then we would have gotten 8 exactly. So this is going to allow us to evaluate common logs as well as natural logs. And so let's look at letter B here. For part B, we have the ln of 0.3. So the first thing I want to do is this, and this is not something that I always do, I'm just doing it for this problem, but I'm going to rewrite it as this right here because they mean the same things. So now in terms of what question we're trying to answer, we're really saying, okay, this base to this power turns into this. But looking at this, rewriting it exponentially, okay, what we're going to see is this. We get e to the power of we don't know turns into 0.3, and this is the question we're trying to answer. And so using our calculator, again, pretty neat here, what we could do is we could just hit our ln key and say 0.3. It already knows we mean log base e, and what we get is this negative 1.20, and I would say 4. So we would say that this is about negative 1.204, and up here on our logarithm now we say that this is 1.204-ish. And so what this would mean is, as we're checking ourselves here, rewrite this exponentially, we'd see that e to the power of about negative 1.204 out to 3 decimal places is approximately equal to 0.3. And just to investigate this here, let's go ahead and type this in now. E to the power of. Remember that your e to the power of button, it's behind your natural log key. Look what's behind your common log key, 10 to the power of button. So we would say that those being the opposite of what we're doing here, we're going to write it in as second ln. We say e to the power of negative 1.204. And what we end up with is something that is very, very, very close to 3/10 here, 3/10. And so we would say that yes, this would be the value of that right there. So common and natural logs, base 10 and base e respectively, and we tend to abbreviate how we write them and evaluate them on a calculator. We'll do that a lot. Cheers.